This is Geometry, section 8.3, part 2. We are continuing with trigonometry. So, one important thing for this section, for this whole chapter, is to make sure your calculator is in degree mode when you're using it. So if you don't know how to check that on your calculator, you hit the second button and then mode. Third row down, approximately, if you have a newer calculator, it might be the fourth or fifth row. So where it says radians and degrees, you want to make sure the degree word is highlighted. So if degree is highlighted, you're good to go. Okay, so continuing with what we did with sine, cosine, and tangent. So remember that this is the saying we want to keep in mind. SOHCAHTOA. That means that sine is the opposite side over the hypotenuse, cosine is the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent side. So using that for this triangle right here, we've got this angle that's 58.1 degrees. This side V is opposite from that, so we might want to make a note that that's the opposite side. And then this down here, 28, is adjacent to this angle. So since we have opposite and adjacent means we want to use tangent. So we're going to say the tangent of this angle, the angle is always going to go after the sine, cosine, or tangent part. We're always taking the sine, cosine, or tangent of an angle, nothing else. So that part, the angle should always go after sine, cosine, tangent, and shouldn't go anywhere else. The ratio that you're writing has to do with the sides. So it should always be angle after sine, cosine, or tangent, and then the sides as a ratio. So tangent is opposite over adjacent. Opposite is V. Adjacent is 28. So we're going to write V over 28. To isolate the variable, the V, we would need to multiply by 28 to cancel it out from the denominator. So then V would equal 28 times tangent of 58.1. So that's exactly what we would type in our calculator. 28 times tangent 58.1. Gives us 44.98, and it says round to the nearest tenth. So if we round that up, 0.98 would round the 9 up, which would round 44 up to 45. Next one, similar situation. We've got this angle right here. W is opposite from that angle, and 19 is adjacent to it. So again, opposite and adjacent means we're using tangent. So now the tangent of 30 degrees, angle always goes after that part, equals opposite W over adjacent 19. So just like we did for the last one, multiply by 19 on both sides. So in your calculator, you would type in 19 times tan 30, 10.96. Again, that's going to round the 9 up, so this would round up to 11 centimeters. Okay, so let's do some examples using sine and cosine. So if this is our angle right here, A is opposite from that 28 degree angle, and now 82 is the hypotenuse. So opposite and hypotenuse means we're going to be using sine. So now the sine of our angle, 28, equals our opposite, A, over our hypotenuse, 82. Again, just like we did for the last ones, we would multiply by 82 on both sides to get the A by itself. So in my calculator, I type in 82 times sine 28. I get 38.49, so rounding to the nearest tenth, that would be 38.5. Okay, next one. So 50 degrees is right here. B, our variable that we're looking for, is adjacent to that angle. And 70 is across from our right angle. That's our hypotenuse. So adjacent and hypotenuse now means I'm working with cosine. Cosine is adjacent over hypotenuse. So adjacent is B. Hypotenuse is 70. Whoops, I forgot my angle here. Cosine of 50. Cosine of 50 equals B over 70. So now, just like we've been doing, multiply by 70 on both sides. So 70 times cosine 50 gives me 44.99. So again, that's going to round up all the way to 45 centimeters. Okay, next ones. So Now this is my angle, 33 degrees. 44 is adjacent to that angle, and C is the hypotenuse. So now when we set this up, adjacent and hypotenuse means cosine. So cosine of 33 degrees equals my adjacent, which is 44, over my hypotenuse, which is C. So now we've got a little bit of a problem because the variable is in the denominator. We need to get it out of the denominator. We need to eliminate fractions. So one way we can do that is to just multiply both sides by the variable and eliminate the fraction. So now we have C times cosine 33 equals 44. Now to get the variable by itself, since C is being multiplied by cosine 33, I can just divide by cosine 33, and then that cancels out. So C would equal 44 divided by cosine 33. So this is what I would type in my calculator. 44 divided by cosine 33 gives me 52.46. So that 6 is going to round the 4 up to a 5. So 52.5. Okay, similar situation is going to happen for the next one because this is my hypotenuse, that's the variable, and this is opposite from this 65-degree angle. So opposite and hypotenuse means I'm using sine. So sine of 65 is going to equal opposite, 53 over d. So again, I can multiply by d. That cancels out, and then I'm going to have to divide by sine of 65. So 53, this is gone now, 53 divided by sine of 65. 53 divided by sine 65. When we type that in, we get 58.47. So the 7 rounds the 4 up to a 5. So 58.5 inches. All right, next example. So now we have two variables. It says use sine, cosine, or tangent to find the variables and do not use the Pythagorean theorem. So we learned a couple sections ago that once you have two sides of the triangle, you can use the Pythagorean theorem to solve for the third side. But since we're going to be rounding here to find the values of the sides, we don't want to use those rounded values when we're solving for the third side. We want to get it as exact as possible. So that's why we use sine, cosine, and tangent. So to start off, this is our angle. This given side is opposite from it. So if we solve for r first, r is the adjacent side to this angle. So opposite and adjacent, again, is tangent. So tangent of 40 degrees is going to equal our opposite, 88, over our adjacent, which is r. So if you're noticing a pattern here, when we multiply by this to get rid of this, then we're going to have to divide by tangent of 40. So whenever you set this up and your variable is on the bottom, you're really just going to take this number on the top divided by the sine, cosine, or tangent, whichever you have over here. You're going to divide by that on this side. So if I type in 88 divided by tan 40, I get 104.87. 104.87, so that would round up to 104.9. And then S. So S is our hypotenuse. So like I said before, we want to use the values that it gives us. We don't want to use rounded values when we're solving for the different sides. So we're going to use this given value. This is our opposite, and we're solving for our hypotenuse, so we're going to use sine. So sine of 40 now equals 88 over S, which is our hypotenuse. And again, this is on the bottom, so S is going to equal this number divided by sine of 40. So 88 divided by sine 40 gives me 136.90, so 136.9. A quick way to check to make sure you're doing these correctly is if I know that this is a 40-degree angle, this is a 90-degree angle, that makes this a 50-degree angle. So across from the smallest angle, which would be 40 degrees in this triangle, should be the smallest side. So 88 is indeed smaller than the side across from the 50, which was R, which we found to be 104. And then the longest side should be the hypotenuse. S is the longest side out of the three of these. So we know we're somewhat on the right track at least. If those don't match up, then you know you did something wrong. If you get that this value is bigger than this value for some reason, then you need to go back and check your work and see what you did wrong, because that should not happen. All right, so this one, 55 degrees right here. If we solve for y first, y is opposite. This is our hypotenuse. So opposite and hypotenuse is sine. So sine of 55 is going to equal y over 145. And again, we're back to the situation where the variable is on the top. So all we have to do is multiply by 145 on each side. So I type that in, 145 times sine 55. I get 118.8 about. If we're solving for x, x is the adjacent side to this angle. So now we're working with cosine because we're given the hypotenuse. So cosine of 55 now equals x over 145. Again, multiply by 145 on each side. So 145 times the cosine of 55 gives me 83.16. So that would round up to 83.2. A quick check, if this is 55 degrees, this would be 35 degrees, so the smallest side should be across from the 35, which it is, and then y is the next largest side, and the hypotenuse is the largest side. Okay, so the hard part, finding an angle in a triangle. If the angle is your variable and you're given two sides to work with. So we're going to set this up the same way we've been setting the others up. So 3 is opposite from this angle, 5 is the hypotenuse. So like I said, the angle always goes with the sine, cosine, and tangent part. So since this is opposite and hypotenuse, we're using sine. And since this is our angle, we're going to put sine of x equals our opposite, 3, over our hypotenuse, which is 5. So now, if we have a situation like this, where I say 2x equals 16, to solve this, I say, okay, well, what's happening with the 2 and the x? The 2 and the x are being multiplied together. So to undo that, I would divide by 2 because multiplication and division are inverse operations of each other. So x would equal 8 here. So we know to do that because we follow our order of operations backwards and we use inverse operations to undo everything that's happening to x. We're going to do the same thing here. So for sine, cosine, and tangent, there are things called inverse operations. So we call them inverse sine, inverse cosine, and inverse tangent. And they look like this. Okay. So if I want to find x, I take the inverse sine of the sine of x. And then this cancels out, and it's just left as x on this side. So just like with every equation, whatever I do to one side, I have to do to the other. So on this side, I'm going to take the inverse sine of 3 over 5. So to type that in your calculator, you're going to type the second button, and then above sine, cosine, and tangent, you should see these little sine -1, cosine -1, tangent -1. Those mean the inverse operations. So I'm going to hit inverse sine of 3 divided by 5. And that's going to give me 36.8, which if I just round it up to the nearest whole number, that would be 37 degrees for x. So this would be a 37-degree angle. Okay, and for this last one, this is the same situation, just using a different trig ratio. So if we have, this is the angle we're trying to find, so we would call this x degrees. This side is opposite. The 5 is opposite from that angle, and the 23 is adjacent to it. So opposite and adjacent means we're using tangent. So we would say the tangent of x equals opposite 5 over 23 adjacent. And then we would take the inverse tangent of both sides. So when I take the inverse tangent of the tangent of x, it just leaves me with x. And then I would type in inverse tangent, so second tan 5 over 23. It's going to give me the angle 12.26. So if I just round that to the nearest degree, we would just call that 12 degrees.